Hello, let's solve this Olympiad exam question for the real values of x in x to the power of 6 minus x to the power of 3 equal to 2. India, can you solve this? Let's look at how we can find the answer to this question. From the expression, we are going to take these two to the left hand side, and if we do that, we are going to have x to the power of 6 minus x to the power of 3, and if you subtract 2 from both sides, we'll have minus 2, and that will be equal to 0. Now, considering the exponent, you will agree with me that 6 can be equal to 2 multiplied by what? 3, right? So that expression will now give us the value of x to the power of 2 multiplied by 3, right, minus x to the power of 3 minus 2, and this will be equal to 0. Now, since we have an x to the power of 3 here, we can simply separate the exponent on the other value of x. So this will give us x to the power of 3, right, all squared, and this will be minus x to the power of 3 minus 2, and this will be equal to 0. Now we can make our conclusion here and assume that the value of our z should be equal to x to the power of 3. So let us let the value of our z to be equal to x to the power of 3. So this is going to give us z squared minus z minus 2, and this will be equal to 0. Good. Now we're going to use the quadratic expression in solving this. Let's think of two values we can multiply that will give us negative 2. That will definitely be 2 and what? And 1. And when we add such numbers, we'll have negative 1. So 2 will carry a negative sign, and then 1 will carry a positive sign. Minus 2 times plus 1 is going to give us negative 2, right? And minus 2 plus 1 is going to give us negative 1. So that expression works. So it can be solved using factorization method. So we're going to have z minus 2, right? And then we'll have z plus 1, both will be equal to 0 using factorization. From here, with the difference of two squares, we can have the first part to be equal to z minus 2 to be equal to 0, and looking at this zero product rule, we can still say our z plus 1 can still be equal to 0. So what do we have? If we simplify this, we are going to see that our z over here will be equal to 2, and that is a solution. While over here, the value of our z can be equal to negative 1, and this is also a solution. Now, this is not a solution because we are asked to find the value of x. So x to the power z is equal to x to the power of 3. So from the very expression, we're going to consider the two results. Looking at the first result with z equal to 2, recall that x to the power of 3 is equal to z. So what will the value of x be? The value of x will now be x to the power of 3 equal to 2, right? So if we take the cube root of both sides, we're going to have the value of x. The cube root of x to the power of 3 equal to the cube root of 2. So what will that expression give us? This expression is going to give us cube clearing the cube root, and then we'll have x to be equal to, this is going to be 2 to the power of 1 divided by 3. And that is a solution to one of the expression that is given to us. Now we can find the second expression if z is equal to negative 1. With z equal to negative 1, we'll have x to the power of 3 to be equal to negative 1. So this is going to give us x to the power of 3. Add 1 to both sides, we'll have plus 1, right? And that will be equal to 3. Now recall that this can be equal to x to the power of 3 plus 1 to the power of 3, and this will be equal to 0. Now think about an algebraic formula. In that algebraic formula, if you recall an algebraic formula, you come to see that we could have a to the power of 3 plus b to the power of 3, that this can be equal to a plus b, right? And this will be multiplied by a square minus the first and second plus b what square. So what do we have? Having this expression, you come to see that a is equal to x, and then we'll have b to be equal to 1. So having that, we're going to have that expression to now give us the value of x plus 1, right? On this other side, we're going to have x squared minus x multiplied by 1 is x plus 1 square, which is equal to 1, and that will be equal to 0. So from this expression, having a zero product rule, we're going to see that the value of our x plus 1 is equal to 0. And on the other hand, we'll see that our x squared minus x plus 1 is equal to 0. Simplify these two expressions, we might most likely have another value for x. Let's see. From here, we'll see that our x is equal to negative 1, which is also a solution. And if we check that, is exactly one of the solution we're going to have for the value of x. While on this other side, we're going to look at this solving this expression using the quadratic formula. But before that, let's test using the discriminant to see if the solution can give us real solutions, because we are finding the real solutions of x. So this will give us b squared minus 4ac. And considering that expression, our value of a is equal to 1, our value of b is equal to negative 1, and our value of c is equal to 1. So our discriminant will now be equal to b squared, which is negative 1 square, minus 4 multiplied by 1 and multiplied by 1. If we simplify this, we're going to have the discriminant to be equal to 1 square is going to give us 1, minus 4 times 1 is 4, times 1 is going to give us 4. So the discriminant will be equal to 1 minus 4 is negative what? 3, which is less than what? 0. So since negative 3 is less than 0, that means this is not a real what? It's not a real solution. It's not equal to a real solution. So this is going to give us imaginary results, and such is not real. So the only real solution we have is just two solutions. The value of our x is equal to -1 and 2 to the power of 1 divided by 3. And these are the two solutions that satisfy that expression we are given up there, which is an exponential equation. Now let's test to see if our solution is actually right. Look at the initial question we are given. We are given the value of x to the power of 6 minus x to the power of 3. Is it going to give us 2? Let's test and see. X to the power of 3 and x to the power of minus x to the power of 3. We'll have the value of x to the power of 6 minus x to the power of 3. Will it be equal to 2? Let's use the first expression with our x equal to -1. X being equal to -1, we're going to have this to be -1 all to the power of 6 minus -1 all to the power of 3. Will this be equal to 2? Let's test it out. We are going to see, since the power over here is even, then this will be positive, minus the power here is odd, and this is going to give us a -1, and this will be equal to, will it be equal to 2? Negative times negative is going to give us positive, so we'll have 1 plus 1. Is it equal to 2? Of course, 2 will be equal to 2, and that tells us that the value of x equal to -1 is solution. Now, what about the value of x equal to 2 to the power of 1 divided by 3? Let's test. If we test that, we're going to have 2 to the power of 1 divided by 3, all multiplied by 6, minus 2 to the power of 1 divided by 3, all multiplied by 6. Will it be equal to 2? This is going to be multiplied by the power of 3, right? Good. So if we simplify that, we are simply going to have that expression to now give us 2 to the power of 1 divided by 3 multiplied by 6, right? And then we're going to have this to be minus 2 to the power of 1 divided by 3 multiplied by 3. While 3 clears 3, 3 here 1, 3 here will give us 2. And then we'll have the solution to now give us 2 to the power of 2 minus 2 to the power of 1. Will it be equal to 2? Let's see. 2 to the power of 2 is equal to 4. 4 minus 2. Will it be equal to 2? Of course, that will be 2 equal to 2. And so that tells us that the value of x equal to 2 to the power of 3, 1 over 3 is a solution. So what does that tells us? That tells us that the two value of x equal to -1 and x equal to 2 to the power of 1 divided by 3 are both solutions that satisfies that exponential equation. Bravo! I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics content. Thanks so much for watching, and bye bye for now.